In this snippet, we're using the Fetch API for a basic GET request. We start by fetching data from an example API. The response is first checked to ensure it's successful. If not, an error is thrown. Next, we convert the response to JSON, a common format for API data. Finally, we log the fetched data to the console. But remember, in the real world, you'd handle this data according to your app's needs. And if there's an error, we catch it and log that too. It's a simple but powerful way to retrieve data from a server. Now, let's dive into Axios, another popular way to make HTTP requests. Here, we're making a GET request, similar to our previous example, but this time with Axios. Notice how Axios automatically parses the JSON response, saving us some code. We simply log the data to the console. Like with Fetch, we also have error handling. If there's an issue with the request, the catch block will execute, logging the error. Axios provides a cleaner, more concise syntax for these operations, making your code easier to read and maintain. Handling errors in Fetch takes a bit more effort. In this code, we're making a GET request again, but this time we're focusing on error handling. First, we check if the response is not okay. If it's an error, we throw a new error with the HTTP status. This is crucial because Fetch doesn't reject on HTTP error statuses like 404 or 500. After handling errors, we then parse the response as JSON. Finally, if any error occurs during this process, it's caught and logged, ensuring our app handles unsuccessful requests gracefully. With Axios, error handling becomes more nuanced and informative. In this example, we're still fetching data from an API. However, if an error occurs, Axios provides detailed information. If the error is from the server, we get the status and response data. If there's no response, it indicates a problem with the request itself. Finally, for other errors, like network issues, we catch them with a generic message. This structure allows us to handle different types of errors more effectively, giving us a clearer picture of what went wrong. In this example, we're adding custom headers to our fetch request. Headers are often required for things like content type or authorization. Here, we set the content type to application, JSON, and include an authorization token. Adding headers in Fetch is straightforward. We simply add a headers object in the request options. After setting these headers, we proceed as usual, fetching the data, converting it to JSON, and then logging it. If there's an error, it gets caught and logged. This is how you can customize fetch requests to meet specific API requirements. Setting headers in Axios is a breeze. In this snippet, we're making a GET request to an API and including custom headers. Just like in Fetch, we need to set content type to application, JSON, and provide an authorization token. However, with Axios, the process is more streamlined. We simply pass the headers object directly in the request configuration. Once our request is made, we log the data received. And as always, we have error handling in place to catch and log any issues that might occur during the request. This demonstrates the simplicity and efficiency of Axios for such tasks. Handling timeouts in Fetch requires a bit of creativity. Here, we use an abort controller to cancel the request if it takes too long. We set a timeout for 5,000 milliseconds, after which the request is aborted. This is linked to our fetch call through the signal property. If the request takes longer than 5 seconds, it gets cancelled, triggering an abort error. For other types of errors, we handle them in the usual way. This technique is crucial for preventing our app from hanging on requests that take too long to respond. Axios makes handling timeouts much simpler. In this example, we're setting a timeout directly in the Axios request configuration. We specify that if the request takes longer than 5,000 milliseconds, it should be aborted. If the timeout is reached, Axios throws an error with the code ECONNABORTED, allowing us to handle this specific scenario. For other types of errors, we catch and log them as usual. This feature in Axios is really handy for ensuring our application remains responsive and doesn't get stuck waiting for a slow network response. Here we're using Async, await with Fetch for a cleaner and more readable code structure, By wrapping our fetch call in an asynchronous function, we can await the response, making our code look synchronous while it's actually asynchronous. First, we await the fetch request, then check if the response is okay. If not, we throw an error. Next, we await the parsing of the response to JSON. This async await pattern greatly simplifies handling promises, leading to more straightforward error handling with the try-catch block, making our code less cluttered and more intuitive. Using async await with Axios is just as elegant. We create an async function, fetch data, to handle our API call. Inside, we await the Axios get request, which simplifies the syntax even further compared to fetch. If the request is successful, we directly access and log the response data. In case of an error, it's caught in the catch block, and we log the error message. This approach with Axios and async await results in clean, easy-to-follow code, showcasing the power and simplicity of modern JavaScript for asynchronous operations.